This week, we speak with Doug Coburn from Signal Sciences. In the news segment, we return to CVEs and persistent bugs, look at Chrome's site isolation to be resistant to bugs. OpenShift hits version 4.2, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 81, recorded October 21st, 2019. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Good morning. Happy Monday.
Good morning and happy Monday. And also a happy Monday to John Kinsella. Hey there, John.
Happy Monday to you, too. I'm just trying to be as happy and chipper as you are.
Sounds good. Thank you so much. We'll see how long that lasts. We do have exciting news, though. That'll keep me happy and chipper for a bit, because the Security Weekly webcast program, we're now partnered with ISC Squared as an official CPE provider. If you attend any of our webcasts, you will receive 1 CPE credit per webcast. Register for one of our upcoming webcasts with Bryce Schroeder and Barbara Kay of ServiceNow, or Steve Lobenstein of Core Security, or all of them, by going to securityweekly.com. Click the webcast dropdown and select registration. If you have missed any of our previously recorded webcasts, you can find our on-demand library by selecting On Demand from the webcast dropdown. Doug Coburn serves as Signal Sciences Director of Professional Services, where he leads the team that installs Signal Sciences in customers' environments. Prior to Signal Sciences, Doug entered the IaaS and PaaS world with Iron.io, doing serverless functions as a service, leading the sales engineering team. With Iron.io, he got introduced to many of the cloud and PaaS platforms that make up the serverless landscape. Before the security and serverless spaces, Doug also worked with companies like Okta, Mocha 5, and IBM BigFix that had elements of security, endpoint management, and identity management. Hi, Doug. Thanks for joining us today.
Thanks for having me again. It's always a pleasure.
Well, I think clearly from your bio, we love having you here, and clearly from your bio, I think you've spent a lot of time working with containers, because I think that's a little bit of the lingua franca of all of the everything as a service that you've touched on the last couple of years.
That is correct. It's kind of been my passion lately, and seems like every customer I work with now is either on containers already or moving very quickly to containers.
So even though customers are on containers, that doesn't really absolve them of all the security that's necessary for their entire application layer. And I think one of the things, especially perhaps with your experience at Signal Sciences as well, and even a little bit of my background, work that I've done in the past, layer 7 security always gets a little bit interesting. And I think there's a big distinction between what it means to run an app in a container and secure the container, and what it means for that application running within it and secure the application. In other words, that container versus layer 7 is kind of what I'm getting at here.
Yep, I would agree with that completely. One of the things that I've noticed when you look at a lot of the vendors out there like Aqua, Twistlog, there's a lot of focus on what's the posture of my Docker container, what's the posture of the security of my Kubernetes platform, and all of the things around it. And then kind of is something that I see as an afterthought is oh, we might have some layer 7 protection kind of off to the side here. But the main thing is my Docker configured correctly? Is my Kubernetes configured correctly? And yet, as we all know, web applications are still a huge source of actual vulnerabilities and kind of the ingress for attackers into environments. And the web application, even if it's in a container, is still going to be your layer 7 kind of ingress point. So if you don't have security at that level, you're still going to be vulnerable and have that container compromised, which can lead to compromise of the whole system as a higher level of access than just a normal system.
Doug, I've also seen kind of the opposite of that, where people would focus kind of on the microsegmentation layer and more around the communication between the containers and not really worry about the configuration of the container itself, right? So I've actually seen it on both sides a little bit with some of the vendors that are in the market. Is some people kind of went after the network communication and build some microsegmentation capabilities for the containers. Others went after the container configuration and security. What I think you're saying is it's a combination of both.
It definitely is. And a lot of what I've seen for the inter-container communication is very focused on that, not focused on the external to the internal, mostly just the intercommunication between containers. So that gives you one visibility. And if you never accidentally expose a service to the internet, you're great. But as soon as you start accidentally exposing services and services that you expect to be internal to the internet, that's where potentially more of that external-based access becomes important.
Yeah, more north-south traffic versus the traditional east-west traffic, right?
Exactly.
Yeah.
Well, and then there's a lot of complexity here too. So how often do you see, teams get tripped up that containers are more of an isolation and not necessarily a security boundary? And how many of them are then struggling to figure out either where that security boundary should be or even how to implement it? Because I think that was a little bit of what you're discussing is, service to service communication or accidentally having that container open to the internet. That there's got to be some way that at least a default baseline security can be improved for not just one container perhaps, but a collection and managing the containers themselves.
Yeah, that's a great question. So there's a few things there. From my experience, especially at IronIO and customers moving to functions as a service or containers in general, is that usually most people, unless it's a brand new application or a newer company, they're moving a monolithic application to a microservices-based environment. So that process is, the first step is usually take that whole beast, put it into one container, and then run it that way. It's fat, it's heavy, it runs horribly, and then slowly you start taking functions out of that initial monolithic application and then putting those into separate containers. But when you start putting those into separate containers, there's thoughts that you might not have had to think about it an individual function layer. When your monolithic application starts up, it might have checks to see, are you sanitizing inputs? Are you looking for particular approvals? Does it have authentication? And a whole bunch of stuff that when you move the function as a separate item might not actually be there. So is authentication gone now and the monolithic application is just calling that, then what eventually becomes a wrapper. So a lot of those security elements kind of get spread out, and you want to start looking at, okay, now how can I protect my individual microservices? So we have some customers that do that at different layers. You can do that at like the ingress controller, where all traffic that's coming in, you're looking for kind of the injection attacks or anomalies, those types of things. And that gives you the consolidated approach. Others maybe decide, actually, I want to see at a microservice layer, and we'll look at traffic at the actual pod or application layer to see what's happening there and potentially set up configurations to block those types of things.
Yeah, so it's sort of, I think you're describing where do you want to choose to place your visibility, and then how can you then aggregate the data that comes out of that, I think is kind of what it sounds like you're describing.
Yep.
Yeah. And so then what about, so you talked a little bit about like injection attacks, I think, or, what comes into the application layer. And historically, I think we haven't had too much there in terms of open source tooling other than, there's the great venerable mod security that's been available. But otherwise, there's a lot of perhaps language functions, pick your language that has input sanitization or output encoding features. What have you seen, those choices, whether people, teams decide to go all in on a container level security and they're omitting that application layer, or perhaps pushing it to a different part in their network architecture, saying here is something that we're going to have in front of our in front of our load balancer, like something like a different type of WAF. How can teams either be successful there, or what are some mistakes they should avoid in making assumptions of how they're protecting that layer 7 traffic?
Yep. So I see a lot of people just say, okay, maybe I have some code scanning to catch things, and that might or might not catch everything. It should probably catch at least some of the stuff, but there's different ways. Some people will do CDN-based WAF and have that in front of their whole Kubernetes controller. Others will use products like ours, Signal Sciences, and use it at the ingress or the application layer, or even make their kind of own WAF layer. What I haven't seen from everybody I've talked to is actually people using mod security of those open source tools. Pretty much everybody that's doing a layer 7 protection that I've talked to personally has been using some kind of paid for product, whether it's Signal Sciences, a CDN WAF, or something that's being put either at the pod inline layer or at the ingress or in front of the whole Kubernetes cluster. But I haven't really seen any of the open source ones.
That's always kind of interesting to me, and I don't have good answers for why that might be. One of my guesses is that with container security and even application security, they're trying to throw too many agents and too many other things into a container that's not focused on what that microservice or what the service itself is actually trying to accomplish. It tends to add a lot of bloat and complexity that, in a way, I think perhaps doesn't quite feel right for DevOps teams as they're trying to manage and do that, the quick iterations and focus on, here's this component, it has one particular function that talks to this other component that has one particular function. And we want to try to avoid, building out a container or, an image, it's like 2 or 3 gigabytes in size. So I wonder how much of it that might be, or if you have other ideas, what might be the case for, people moving in that direction.
I would say actually the biggest thing is going to be central management and how you actually deploy these types of products. So being able to deploy easily in a container, whether that's sidecar in the same app or the ingress controller or in front, is going to be a key element. And then also, how do you manage those rules centrally? So it's already hard enough if you have 1 or 2 web apps, but now you have potentially 10, 15, 100, 1,000 microservices. So you need to be able to manage those rule sets across all of them in an easily configurable way. Whereas with some of those traditional open source ones, you effectively would have to manage it at a per pod or per service in Kubernetes layer. And if you have 100 or 1,000 of those, it simply becomes unmanageable and you wouldn't even know what's actually being configured.
Could also potentially limit some of the portability too, because if you're running specific images or versions with certain endpoints in them or agents in them, some of your flexibility goes down potentially as well, right? And so when you think about the infrastructure this stuff gets deployed on, it could be dedicated infrastructure. It could be a Fargate, right, which is kind of the far extreme of there's really nothing there except for the container itself, right? That also plays in a little bit, I think, into the architecture you've been talking about, Doug.
Yep, it has a huge part in it. Yeah, you have all of the KS services, so PKS, GKS, AWS, Kubernetes, so all of the kind of hosted Kubernetes services where potentially the ingress layer is abstracted and you're using their actual load balancers in front of it. Then you have the even further steps, which is the Fargates, where you just worry about the container, and that gives you even less control of where you put things. So if you're using one of the Kubernetes as a service, you probably don't have access to the ingress controller. So you're going to want something at the pod layer. Whereas if you're using a different service where you have access to the ingress, maybe it makes sense because you set things up once and everything is protected. Also, it's not just a technical limitation, it's a political limitation. If you're setting things up at the pod layer, that usually now belongs to the app owner or the function owner. And you have to get their buy-in to add a second container or another agent or whatever it may be in order to actually implement there. So it's a little bit of technical and a little bit of political in order to determine how you actually protect those layers.
And you don't want to give up root. Sorry, I had to throw that in there.
Yep. Yeah, giving up control to people, especially from, like, say, an app owner to the security team, is sometimes hard because there could be contention there. I think we've seen some shifts that is with the kind of DevOps approach, people are being a little bit more security friendly from the get-go, and security becoming a little bit more of enablers as opposed to blockers.
That brings up a really good point, because you're kind of focusing on where are the smart places to invest security, and you're talking a lot about abstracting it so that it can be externally managed from the container, so that it can be also then centrally managed and react more quickly. But if we're also talking about then the application layer security, the first point we start talking about it shouldn't probably be that point where we're deploying it and trying to inspect traffic coming into the container. And you mentioned, a little bit ago, running source analysis tools. And so that's probably also a smarter place to start to invest at the application layer security, as well as even just having those discussions with the DevOps teams, call it like that political angle or that collaboration, that the security teams come in and say, how are you designing this application so it's going to be more resistant, it's going to be more isolated, it's going to limit the type of data access it has, so that when we talk about the container security, we're talking about isolating and maybe sandboxing a compromise so it can't pivot or bleed into peers. And the layer 7 is not quite an afterthought, but its purpose isn't necessarily as a preventative, but perhaps more so as a detective control to see if we miss something, speaking as a developer, miss something, that application layer, or a quick reaction to have that so-called virtual patching when they have some type of known vulnerability in a dependency, which is one of those things that seems like an unavoidable problem for application owners.
I agree completely with that. Security really starts before you actually even developing the application. If you have the right kind of mindset and it's part of your core tenets as you're developing, that's going to definitely help you build a more secure application as you go through. You want to get as many of the vulnerabilities out before you ever actually deploy it. But actually, when you're doing the DevOps and agile approach, it's even quicker to potentially get a vulnerability in. So being able to see attacks come in and then also be able to react quickly and block it while you figure out how to resolve it, whether because it's a third-party dependency, or another thing I've seen is like you have new developers coming in, maybe as interns, they have a new project, they're not very experienced or very security conscientious yet, might introduce a vulnerability, and that can actually be deployed out very quickly. And I actually have an example I've set up. It's a little bit of a kind of demo environment, but it shows how quickly a vulnerability can get out there into the wild.
Yeah, let's take a look at that, because I think that will give us a good, build up that story about why we're looking at security from, everybody says shift left, but we can also just say in this case, start left and then watch it progress all the way through the containers into deployment.
Correct. So let me go ahead and share my screen. So that should hopefully show up and be visible to everybody.
Yep.
Awesome. So I have this simple SCIM server that I actually wrote for Signal Sciences for provisioning. And in here, I do have a little bit of a silly code that I would hope nobody would ever do in real life. And in this GitHub repository, so if we look at the actual source code, I have this /silly code that takes a parameter and just takes it as is and does a system call, which would allow me to do a code execution. And if people are familiar with it, there's a tool called Circle CI that I used in this example that allows me to be able to have a pipeline where it has a project that's defined in a configuration file that will go through, do tests, and in my case, actually build a container and then deploy it to my Kubernetes environment. So I then have, after my Circle CI, I have the actual endpoint service in Kubernetes, where when I hit this, right now, this endpoint doesn't exist because I haven't actually checked in my code. So I'm hitting a web page with a potential vulnerability or command execution. When I come into my code, I can come into here, uncomment the endpoint that's going to take that URL parameter and effectively execute whatever that query is. And maybe it was a quick shortcut that somebody got to work, but hopefully would never again do this in real life. So I can check this into GitHub. I'm doing my commit here. And then I'm just going to push my change to GitHub. The cool thing about using these Circle CI and these other kind of pipeline tools is just pushing this change to the GitHub repo, it's actually monitoring that. So when there is an update, we see a new job starts running automatically. And I have a set of steps defined in the configuration file for Circle CI. And it's pretty straightforward. And this repo is also public, so if anybody wants to look at it, they definitely can. And we can see each step that I'm doing. I'm also, in this case, I've set it up to build and push a new Docker image, which at the end of the day is going to actually update my Kubernetes deployment so that the image being used here is going to be updated. So we can see right now it's on version 37. If my build is successful, and hopefully I have everything correct, so it was pushed to Kubernetes, we're actually going to see my deployment is updated. It's actually in the middle of deploying version 38. So I've now gone through a full pipeline, had a successful build. It's now come up, and I can now execute the actual command execution against that query. This right here is the actual task ID or the process ID of cat actually running. If I were to look at that actual log files from one of those pods, I can kind of come into a pod here. I can actually go into the logs if I want to and see what is going there. And in there, I'm going to see information. Oh, there was a cat called. And this now just got through. So very quickly, I have a vulnerability. And this comes also to, I have a second service here. In this case, I have a separate layer with the Signal Sciences as the WAF layer called reverse proxy. And what that does is allows me to be able to actually block command execution type events. So even though this endpoint is vulnerable, if it wasn't exposed to the internet like it is at the moment, I'd actually be blocking it before it got there, even though it actually had the vulnerable endpoint, and then be able to see data about those attacks coming in. That was a quick run through of kind of that environment, but as we saw, I made one code change, pushed it, and within less than a minute, that now vulnerable code had been deployed and was fully available.
But because you had Signal Sciences WAF in place, you actually blocked that vulnerability, kind of like a virtual patch in some respects, right? Because you stopped that command execution at that layer.
Exactly.
Yeah.
Yeah. So it's very much like the case, you even called your endpoint silly, which is funny, which is, makes sense. But it speaks to a very practical scenarios when there is something, a mistake happens, something slips through the linter, the source analyzer, something changes so that the code is now vulnerable in production, open up to the world. And now there does need to be, at the very least, some way to detect that there's a problem in that code. And then ideally also some way to actually prevent it from being exploited. And I think that's what we've just seen here with your...
Exactly.
Yeah. So if we were to talk this through, and so one of the benefits, I guess, too, of the model of not just putting the layer 7 security in the container itself is that just as much as we could say here is the silly endpoint with RCE as a service, somebody could also have easily made a mistake in that, in the layer 7 security rules that could have weakened the block for that, or could have turned off the block. The security for that. So there's probably also a good story here to build in the sense of separating the control of your controls into either different populations of admins or into different areas of your architecture so that they're more resistant to human error or human mistakes, and they can more easily complement each other as well.
Yep, and I see that most often. Usually there'll be a team that's kind of in control of the security products and probably set up that more kind of restrictive environment, whereas the app owners would focus on the app. And if they did notice the vulnerabilities, maybe you're just in logging because you wanted visibility, you could quickly switch it to blocking. But having that central management is kind of a key element, kind of back to my earlier point why I don't think we see a lot of the open source ones, is being able to easily manage and see what's going on is critical when you start getting into the microservices world, because the number of things you need to work with just grows dramatically compared to a monolithic application.
Speaking of that, things that are growing dramatically, we saw here it's a good example of one to drive home the idea here of what a silly RCE looks like. But what happens when this scales? So in the sense of either more deployments or a few thousand microservices sitting in a large organization, and then requests per second order in the measure of a few thousands. And so you have a massive amount of data coming in and potentially even alerts from your either layer 7 security or just your layer 7 logging. So at that point, that when scale comes in, does this story change, or how does this story change, and what can teams do to handle that or be forward looking as they architect their systems?
That's where I think the central management becomes even more important, and probably layer 7, in my opinion, becomes really critical, because when you have hundreds or thousands of services, something is going to get missed. It's just is the likelihood, the statistics behind it. There's something that will get missed, get accidentally deployed. Maybe it was a dev environment that was testing that accidentally got pushed to prod. There's just so many ways for that to happen. But when you kind of start abstracting, even if you have hundreds or thousands of services, those are usually comprising a single application or a single service. So if you start logically breaking those into kind of your views, then even though it might be 100 microservices that makes up app A or service A, it'll actually still just be a bunch of endpoints and things like that now kind of become a little bit more logical in sense. And you can get a view of what's actually going on, along with if there is intercommunication attacks. So maybe a service did get compromised, you would start seeing those attacks from an internal Kubernetes address or whatever your orchestration platform is, along with any external ones, and be able to tie that up to endpoints, and then be able to figure out and attribute which microservice comprises those endpoints, so you can go and update those vulnerable actual microservices.
Yeah, we thought that correlation was really hard to do at the network layer. Now think about it in a container world where things are really spread out, and you've got network components and non-network components and the Kubernetes orchestrator and the containers and layer 7 north-south traffic. There's a lot of pieces to correlate to kind of figure out what's going on and where is that attack, what needs to actually be updated, because you need to bring all those points together in these highly distributed applications.
Yeah, so one of the customers I work with has literally thousands of microservices, and because the pods are named in such a way that attributes it to their actual app owner or developer, you can look at an attack and see which agent that attack came from, which tells you which microservice, and then you can immediately go and attribute it to that development team.
Interesting.
I'm really curious. It's great when you can find an owner, but a lot of times that ownership inventory goes stale, or people don't even necessarily realize they own something, or the team is completely moved on or been reorged somewhere else. Are there ways that you've seen to be able to leverage that type of information, that application layer traffic or something similar, to help maintain a manifest of your app inventory, or as well as even just who the real live owners are that actually realize they own some of those apps?
So I think if people move on, it's a bit harder, because then it might just be completely unknown. But that becomes very obvious because you figure out it's this particular microservice. Well, first of all, you can mitigate an attack, because you can say, actually, I'm just going to block this type of traffic. And that mitigates the attack in the first place, even before you solve it at the app owner level. But at that point, you go, okay, I have an app owner. I know which microservice it is. And when you go and say, actually, everybody says nobody's working on that anymore, that's an internal process thing to fix. What I've seen is companies mature on their kind of DevOps approach. It's usually teams or bands that are responsible for particular types of services, and those get assigned to them. So if the team or band does move on, then it's just a matter of kind of re-triaging and saying, we have a new vulnerability, we're blocking it. Here's the microservice, which band is going to be now working on these types of tasks, and take it over.
That requires a level of maturity within your DevOps process, which is, some organizations are further along than others in that respect.
Yeah, I would agree. I mean, no matter what, if it's not owned by anybody, you still have to find somebody to be responsible for it, and somebody has to take ownership, regardless of if you have a full kind of mature DevOps approach or not. So you can attribute and figure out, and that's, I think, the most important part is what bit of code is vulnerable, which means that you can either find the person responsible or make somebody responsible for it.
I've been sitting here quiet because these guys are asking a lot of good questions, but we've been thinking about this a lot recently too, and it seems like ownership, application ownership, really it varies from one org to the next and how they actually do it. I'd love to see some sort of a standardized way that, like, you drop Signal Sciences or anything else into an org, and it's able to go, oh, this particular container is owned by development team number 63 and something like that. It's. Have you heard anyone working on anything like that, like a sort of a standardization around this?
Not really. Every company I worked with, generally it's internal tracking of who owns a particular kind of function or application. There is no kind of equivalent of the traditional endpoint kind of inventory management type system, which is almost like what that would be.
Because what you really need there is, it's one thing to be able to display that again in your guys' UI, but it's the compliance and the enforcement of it. That's what I've seen really is missing, because that's something then that has to be sort of, not just are you coming up with your way to track and label that the services, but also how do you ensure that they have that label on there?
Yeah, there's no great way, because that is up to the person who's actually deploying if you do it at that layer. So it's really, if you're deploying at the pod layer, you need to be in a partnership with your developers to make sure that they're following conventions. And also whoever's managing the security layer can go back and say, well, what's this oddly named one? And then have to go and find out who that actually belongs to. If you do it at the ingress layer, you lose some of kind of that visibility, because you're only seeing the requests come in at the endpoints, and you don't necessarily know exactly what microservices that it is actually responsible for. So it makes it harder. I would say from an attribution layer, kind of the pod gives you that best visibility and control. But at the end of the day, a lot of it comes up to the company policy and process and enforcement of that process within the organization, because otherwise you're going to get random names. It might be container name -IP, or it might be something else that you look at and go, yeah, I have no idea who that belongs to.
Yeah, you almost need a set of tags to check in, to track the developer, the container, the pod, the microservice, probably the API communications back and forth, because again, there's all kinds of communications under the cover that's happening, and it's correlating all that and understanding all those interdependencies in a way that allows you to track down a specific vulnerability to a container on a pod and say, okay, who owns it? It's not that easy. I mean, it sounds easy, but it's actually not.
No, and the larger the organization is, the harder it becomes. And that's really where a process has to be defined within the organization that says, okay, maybe every pod or deployment name is going to be like an ID, which might be the dev app team ID dash, maybe what service it is dash, a whole bunch of identifiers, so that it's very easy to see that. And then as soon as somebody doesn't follow that, you go, okay, who is this? Otherwise we're killing it. And then you kill that and people start screaming that their thing isn't working, and you're more likely to find them. But it does have a reliance on that partnership between the security and app teams and people following the process.
Mm-hmm. Yeah, I would have caught Paul's issue when he had a rogue container running on our Kubernetes cluster.
Exactly.
Yeah, I think you make a great point about just establishing the naming of things is an important step, an important contract amongst all the players, because otherwise you get to the point where it becomes we're going to have to turn this service off, or we're just at least going to block traffic from it for a brief period, see if anybody notices. Once they start noticing, then you can also say, here's the story that if you were that dependent on the service and the service is unowned, it just might have to be that you have now inherited it because it's so critical to your own system. And conversely, if you're lucky and no one objects, then you can also say, taking this down or blocking it hasn't really impacted anyone. So maybe now it can be retired, and it's an orphan that can be sent off somewhere else into the metaphor where orphans go and live happy lives somewhere. I don't know.
Exactly.
Well, Doug, I think speaking of knowing who to talk to, I think you've been a great person to talk to, talking about container security and application layer security. So I want to thank you once again for joining us.
My pleasure. I'm always happy to be here.
Thank you, and thanks to Matt and John for the chat as well. We're going to take a quick break, and then we're going to return with news of the week.